Welcome to Techtonic. In this video, we're tackling one of the most common questions around wireless technology. Is 5G safe? And should we already be worried about 6G? There's a lot of fear online, but also a lot of confusion between different types of radiation, different exposure levels, and what regulators actually measure. So, in the next few minutes, I'll break this down in a simple way using science, public safety standards, and what global health agencies have actually said. The goal here is not hype and not fear, just signal, science, and truth. Here's our roadmap. First, we'll answer the core radiation question, because everything starts with understanding the difference between ionizing and non-ionizing radiation. Second, we'll look at what the scientific evidence actually shows after decades of review. Third, we'll see how regulators set safety limits, because these limits are not random. They are built through a structured process with a large safety margin. And finally, we'll look at where 6G stands today, so we can separate what is already well understood from what is still under study. This is the most important distinction in the whole debate. Ionizing radiation carries enough energy to knock electrons out of atoms and directly damage DNA. That includes things like X-rays, gamma rays, and high-dose ultraviolet radiation. Non-ionizing radiation is different. It does not carry enough energy to break chemical bonds or damage DNA directly. That is the category 5G and 6G radio waves fall into, along with Wi-Fi, Bluetooth, and even visible light. So the real safety question for 5G is not DNA damage. It is whether exposure could cause heating, and that only happens at levels far above public exposure limits. In normal daily life, real-world 5G exposure is usually only a small fraction of those limits. When people say the science is unclear, it's important to ask, unclear compared to what? We already have more than 33 years of radio frequency research, and over 25,000 peer-reviewed studies have been reviewed by organizations like the World Health Organization, ICNIRP, and telecom standards bodies. The broad conclusion has been consistent. Within established public safety limits, there is no consistent evidence of confirmed health harm. That doesn't mean science stops. It means the evidence has been reviewed repeatedly by multiple independent institutions, and the limits already include a major safety buffer before the public ever gets exposed. Safety limits are not chosen casually. Regulators follow a step-by-step process. First, researchers study how radio frequency energy interacts with cells, tissues, and whole organisms across many experiments. Second, they identify the level at which measurable heating begins, because heating is the main established effect for non-ionizing RF exposure. Third, they divide that threshold by 50 to create the public limit. That means the legal exposure ceiling is set far below the level where known effects begin. And fourth, the process does not end there. Agencies keep reviewing new data and update guidance when necessary. So the limits used for 5G are designed to be precautionary, not borderline. Now, let's talk about 6G. As of 2026, some parts of the picture are already well established, while others are still being studied. The well-established side includes sub-6 GHz bands, which have a safety profile similar to 4G and earlier wireless systems, and millimeter wave bands, which are absorbed mainly in the outer layers of the skin rather than penetrating deeply into the body. ICNIRP's 2020 framework was already designed to cover frequencies up to 300 GHz, which overlaps with many proposed 6G candidate bands. What is still being studied are the higher sub-terahertz ranges, long-term skin and eye exposure questions, dense deployment patterns, and newer antenna behaviors like AI-driven beamforming. So the honest takeaway is this: 6G safety is not a blank unknown, but it is also not treated as finished science before rollout. This timeline is useful because it shows that safety work has been moving in parallel with technology development, not after the fact. In 2020, ICNIRP updated its guidelines to cover 5G and 6G related frequencies up to 300 gigahertz. Around 2022, ITU-R began shaping the IMT-2030 vision, which is essentially the global framework for 6G. By 2024, early sub-terahertz prototype trials were already happening in countries like South Korea, Japan, and Finland. Around 2027, 3GPP Release 21 is expected to lock in major 6G standards, and commercial deployment is generally targeted closer to 2030, so this is a staged process: research, framework, standards, trials, then deployment. So what should an informed viewer actually pay attention to? First, prioritize peer-reviewed sources, journals, established agencies, and published reviews, not viral posts. Second, check primary sources directly, especially ICNIRP and major public health bodies, because that is where exposure frameworks and evidence reviews are published. Third, be careful with dramatic claims about suppressed evidence. If the claim is real, there should be an actual study or review to point to. Fourth, trust the fact that safety standards are updated over time as evidence accumulates. And fifth, remember that your real-world device exposure is typically far below allowable safety limits. In other words, critical thinking matters more than fear. If you found this useful, go deeper with The Signal, my weekly newsletter where I break down 5G, 6G, AI, and emerging technology without the hype. If this video helped you understand the topic more clearly, like it, subscribe to Techtonic, and share it with someone who still has questions about 5G or 6G safety. The more we replace confusion with evidence, the better these conversations become.